Hi friends, this is Gaurav, and learn. Today we will solve a question from the chapter Work Energy. It is a solved example from C. Verma. So let's see. It says a uniform chain of length L and mass M overhangs a smooth table, and with its two-third part lying on the table, find the kinetic energy of the chain as it completely slips off the table. So this is the situation, and this part of the chain is hanging. Its length is L by 3, and the part which is lying on the table, it's 2L by 3. This Since there's a smooth table, this will fall off, the chain will fall off from the table. So let's calculate the potential energy of the part of the chain which is hanging. If we assume that the potential energy at this point is zero, we will calculate the potential energy of the part which is hanging. So potential energy is given as mgh. Since we are taking this as zero, it will be minus mgh. We will first calculate the potential energy of the small part which is at a distance of x. So the mass will be m by L times dx. This is the mass of the small part dx, and multiplying it by g, we get the weight, and multiplying by x, we get the potential energy. And since it is in negative, we'll put a minus sign, and we will integrate this from uh, uh, 0 to L by 3. So this will come out to be m by L times g, and a negative sign here, x dx, and integrate it from 0 to L by 3. This will give the potential energy of the hanging part. So minus mg by L um, x dx will be x square by 2, and is from 0 to L by 3. It will come out to be minus mg by L times L square by 18. So here we will cancel out the L. This comes out to be minus mgl by 18. When the chain is entirely falling, when the entire chain has fallen, then what is the potential energy of the entire chain? That we have to calculate. The difference in these two potential energies will give us the kinetic energy. This will be minus mg by L integration x dx from 0 to L. This will give us minus mg g by L x square by 2, 0 to L. This comes out to be minus mg by L, L square by 2. This is minus mgl by. This is the potential energy of the chain when it has entirely fallen. So in work energy, there is a concept that when there is no external forces and only internal conservative internal forces are acting, then the initial kinetic energy plus initial potential energy is equal to final kinetic energy plus of final potential energy. So initial kinetic energy is zero. We know the initial potential energy, we know the final potential energy, but we don't know this. So we can easily find the Kf. Kf will be initial potential energy minus final potential energy. So now calculating these two, we get initial potential and K final is equal to initial potential energy, which is minus mg L by 18 minus final potential energy, which is minus mgl by 2. So this comes out to be mgl by 2 minus mgl by 18. If you calculate it, it will come out to be 4 mgl by 9, which is our answer.